Hi, today we're going to work on adding and subtracting polynomials. So let's get started by putting your name on the top. Never lose your papers. No way. All right, so what we're finding out is when to use our exponent rules that we've spent the last several days on versus not. And what I need you to see, the basic theory is if you're multiplying and dividing with the exponents, then yes, you have to change exponential values. But if you are purely adding or subtracting terms together, no. Those stay what they are the whole time. So first, let's get started by finding the degree of each monomial. So let's define that real quick. A monomial is one term. It's just one piece of information. Nothing is added or subtracted to it. One term. That's where that old phrase that you might hear in old people movies like mine, I'm gonna fight you after school, mano y mano. It's just one versus one. Nobody is jumping in. There's not a tag system. It's just one person fighting one person, mano y mano. Okay? So the degree is the largest exponent. Has nothing to do with the coefficient out in front. It is the largest exponent in the term. Largest exponent. Okay. So here on problem number 1, this is a monomial, and these are my exponents that I'm looking at. And they happen to be the same, and they're the same as my coefficient. So there's not a lot to choose from here. So my largest exponent, my degree, it's a 2. Done. Wasn't that great? Okay, let's look at number 2. So in number 2, I have a 5, but that's my coefficient. I need the exponent. The exponent that's right there. So if there's nothing showing, what's that value? We've talked about it. That's right, it's a 1. And so this has a degree of 1. That's it. It's done. Okay, pause the video. Go do number 3 and number 4. Let me know if you need some help. Okay, here we are looking at problem number 5. Our instructions are to write each polynomial in standard form. So let's underline what standard form. We're going to talk about that. And then we're going to name each polynomial based on its degree and the number of terms. Okay. So standard form. You're going to write it in order from the largest exponent down to the smallest exponent for each of the terms. All right, let's look at number 5 together. So remember, we are specifically only looking at the exponents. So we can even box them up. I'm not looking at the coefficients, just the exponents. All right, Which one of those terms has the largest exponent? There it is. So let's write that first. 3x to the 4th power. Okay. Which term has the next largest exponent? Right, it's this positive 2x, and it's positive, so we're going to take that plus sign with us. Positive 2x squared, excuse me. And then we've got a 5x and a minus x. So truthfully, these have the same level of exponent on them, and we're not finished. We need to combine like terms. These two terms have the same exponent. So let's combine them together and come up with what it's actually worth. So my final standard form is 3x to the 4th plus 2x squared, and then 5x's minus 1x. So 5 stars minus 1 star, that'll be a positive 4 stars, except it's x's, all right? So this is my standard form. That's it. So what is its highest degree? It's a 4. And how many terms are here listed? There are 3 terms. And this polynomial, poly means many, a polynomial that has 3 terms is called a trinomial. That makes sense. It has 3 parts. What would a 2-part polynomial be called? So if you don't have a car and you don't want to walk, you use a bicycle because it has 2 wheels, so it's bi. So we have a binomial for 2 terms, monomial 1 term, trinomial 3 terms. More than that, we just call it like 4 terms, 5 terms, 6 terms. We just cheat. Okay, you do number 6. Super simple. Go. Let's look at number 7. So in problem 7, we are instructed to add these 2 binomials together. So you first have to look and see what's my instructions, and we're told to add. We know we're going to combine like terms. That's what we're doing. So you have to put the variable with the same exponent together to combine them. So let's write that note down. Same variable and exponent. The deal is you cannot mix and match. That's a big no-no. You cannot do that. So let's look at number 7. We are just adding. We're going to do whatever it is they tell us to do. So if it's written vertically like this, usually it's already lined up. So the z goes with the z. The constant goes with the constant. So that's usually very nice in just the setup. It's also great for someone who's more visually oriented to help them figure out what to put together. So 8 zebras plus 6 zebras, you can just say 14 zebras or 14z. It's not 14z squared, it's just 14z. All right, and then negative 12 plus 9. What is negative 12 plus 9? That's right, it's negative 3. This is your final answer. Can't do anything else with it. That 3 doesn't have a z on it. So it's equivalent to saying 14 zebras minus 3. Minus 3 what? I don't know. Was it minus 3 other zebras? No. Well, how do you know that? Doesn't have a Z. Well, minus 3 what? I don't know. So you just leave it, and it's done. You do not make that a 14. Let's try number 9 together. So this one has the exact same concept. We're adding to combine like terms. But this time it's not written vertically, it's written horizontally. So we look and we say, oh, first off, are all of my variables the same? This is a K, this is an X. They are not the same. They're both squared, yes, but remember, has to be the same variable and exponent. So I have the exponent part, but not the same variable. So standard form says that we write them in order alphabetically. In the alphabet, K comes before X, so this will be 3K squared. This is a positive 16X squared. And then we're going to put the constants together, because this is a simple 5 constant. This is a simple 7 constant. So positive 5 plus 7, 5 plus 7 is 12. And you're done. There is nothing more that you can do for that problem. That's it. All right, why don't you stop the video and try to do number 8 and number 10. So if you need a little help, come and ask me. Let's talk about number 11. Number 11 is a little bit different because our instructions are different. This is a minus. So when you are subtracting, the problem that I see students run into is they always remember to make the first term the opposite sign to subtract it. But they forget to change everything else that's inside of those parentheses. So when I do these, I tell people right now, change the signs on that bottom row. Whatever it was, switch it. So the 8 inside of the parentheses, that was a positive 8, but the negative turned it to, the negative outside turned that 8 negative, and it turned the 2 negative. So now 7x squared minus 8x squared is, what is 7 minus 8? Yeah, it's negative 1x squared. So the x squareds are still very present, very visible. Don't drop those. But just do your normal subtracting of the coefficients. And then let's finish this off. 9 minus 2. Yeah, that makes positive 7, just like it has your whole life. Now, I have a 1 in front of this x squared. Do you have to have that there? No, you don't. Is it wrong? No, it's not. It's just to help you to realize, oh, there's 1 of that x squared. But remember, if you were looking on a test, on a quiz, on your state test, the 1 won't be present. It will just be read as negative x squared plus 7. And that's it, you're done. Let's look at number 13 together. 13 is written horizontally, and again, it has a subtracting in there. So before we get started doing combining like terms, we need to distribute this minus through the parentheses that come after it. So let's rewrite our first information, 3a squared plus a plus 5. And now let's distribute the minus through these parentheses. A negative times a positive, it's a negative 2a. A negative times a negative is a positive 5. See how we did that? We changed the signs on that second set of parentheses so that we can do our combining correctly. Okay, so here's a squared term. Do I have any other squareds? Nope. So I just have 3a squared. Got it. Here is a simple a, and here is a simple a. How many is this positive a? Good, that's one of them. Remember, there's an understood invisible coefficient of a 1 in front if nothing else is there. So positive 1 minus 2. What is positive 1 minus 2? Good, it's minus 1. Minus 1a. And then finally, positive 5 plus positive 5. What does that make? Yeah, it makes 10. 5 plus 5 is 10. So we remember from our discussion in number 11 that if this was on a worksheet or a STAR test or on a quiz, you're not going to see this 1 in front of the a. So let's rewrite correctly for the full final answer. 3a squared minus an a plus 10. There it is. Okay, why don't you stop the video and do number 12 and 14. See how you do, and if you need some help, come and talk to me. Let's look at number 15. In number 15, a small town wants to compare the number of students enrolled in the public and private schools. The polynomials below show the enrollment for each one. Okay, so here is my public school, and that's how many kids they've got going on there. And my private school, much smaller it would appear, that's what they've got going on there. So we're going to write a polynomial for how many more students are enrolled in the public school and the private school. Did you catch this? It said how many more. What does that mean? Add, subtract, multiply, or divide? Good, it means subtract. Okay, good. So what are we going to subtract? Yeah, we know it's the public school and the private school, but which one comes first? Yeah, this is going to be public minus the private. Okay, so let's go set up this polynomial, and that way we can combine the terms. So we start with negative 19c squared plus 980c plus 48,989 minus everything that was in the private school. The private school was 40c plus 4,046. Alrighty, so here we are now, just like in number 13, let's distribute this minus through the quantity that came after it in those parentheses. So let's rewrite. Negative 19c squared plus 980c plus 48,989. A negative times a positive is a negative 40c, and a negative times another positive is a negative 4,046. All right, let's combine like terms. Negative 19c squared. Is there another c squared present? No. So let's write that. Negative 19c squared. All right, so now we've got 980c that I need to combine with another term. Do I have another term with just a simple c? I sure do. Minus 40c. So what is positive 980 minus 40? Positive 940c. You see how I did that? I just did a little bit of subtracting. And finally, we have this huge constant of 48,989 minus 4,048. What do you get? You got a calculator and a great brain. If you got 44,943, then you did something really great. And that is how many more students are in the public school than the private school for that town. Okay, you do number 16. Let me know how it goes, and I'll be glad to help you out.